11.2, similar triangles. Take a look at these two triangles, and we notice it's pretty easy to tell they're not congruent, which would be this symbol. But if I say this angle is equal to this one, let's just say triangle ABC, and this is triangle XYZ, then if we make angle B is equal to angle Y, and angle Z, angle C. Okay, all the angles are the same, and that's one condition where this would say, okay, if that's true, then these triangles might be similar. The other thing that must be true is the sides must be proportional, which means that if we compare some of these sides together, like 10 and 20, okay, what do you notice is going on here? Compare two of the other sides together. So the 5 and the 10, and notice those are also the same ratio, 1/2. And then the other side, let's do that one purple, 12 and 24. Those are also in the same ratio. And it doesn't matter which number's on top and which one's on the bottom. You're going to get the same ratio because 20/10 is the same as 10/5, and it's the same as 24/12. So we have to be consistent. If I put the number from the smaller triangle on top one time, I have to do it every time. But I can also compare other sides. Notice if I compare the 10 and the 5 in triangle ABC, then I could compare the 20 and the 10 in triangle XYZ. So, and notice those are both equal to 2. And then I can do the same thing. I could say even 12/5. Notice I'm going this and this, so then I have to use this and this. These should be the same, 24/10. Is 12/5 the same as 24/10? That's a little bit not as obvious. But if we do a little bit of work, if we cut this in half, we could see it's the same. That's 24 divided by 2 is 12. 10 divided by 2 is 5. So that's what I mean by the sides are proportional. Sides proportional. Okay. So if those two things are true, then these triangles are similar, and we get rid of one of these, and we say triangle ABC is similar to triangle XYZ. Okay, so now what are we going to do with this? We'll do some problems like this, where you've got two triangles. It doesn't tell us that they're similar, but we should know that they are. Because if these two angles are marked the same, then the third one must be the same. Let's put 3 tick marks on it. How do we know that one must be the same? Well, these angles must add up to 180 degrees. And so if I already know 2 of them, the third one must follow by subtracting the other 2. So now I know these are similar. I can set up a proportion, or I can set up a lot of proportions. So whatever one jumps out at you is the one you should set up. My eyes go right to this. 4 corresponds to 6. So I'm going to put 4 on the top, 6 on the bottom. And then G is the one I want, and that corresponds. Let me make my G kind of like their G there. It's a hard-looking G. And then, because that's going to look like a 9 if I do it the way I normally do a G. So then 9 goes on the bottom. Okay, that's one proportion we could use to solve this. From there, we cross multiply. So G times 6, I'm going to write my G. I'm just going to do capital G. 6G. And then 9 times 4 is 36. And now to solve for G, we just divide by 6. G equals 6. But maybe you saw maybe you saw something different. And it actually doesn't matter. As long as we're searching for this G. So maybe we compare G and the 7. And I say, G over 7, can I do that? Well, if you do that, then you have to use the 9 and put it over the 10.5. Because we use the 7 and the 10.5 correspond to each other. Is this going to be the same? Kind of feels maybe like it won't. But If we cross multiply, 9 times 7 is the 63. 10.5 times g, I don't know. I'm just going to write 10.5 times g. And now to solve this, all I have to do is divide by 10.5. 63 divided by 10.5 turns out to be exactly 6. So there's a couple ways to do this. You can even flip the fractions completely over. 6 over 4 is equal to 9 over g. It's the same thing. And same with the other one. So just depending on how you see it, set up a proportion, cross multiply, and solve it. Okay, another one. This time we've got two triangles that are like reflections of each other. And we should know they're similar because these angles are called vertical angles, and they must be congruent. And now I know two angles in both triangles, so that third angle must be the same. 1, 2, 3, 1, 2, 3. And if all three angles are the same, the triangles are similar, which means the sides are proportional. So now I have to figure out, okay, which sides correspond to each other. It's probably easiest to tell that n and 36 correspond. So I could write n over 36, or I could write 36 over n, doesn't matter. Just as long as I'm consistent with the next one that I pick. And the next one should be involving two numbers, but I can't just pick any random numbers. I need to figure out what sides correspond, and it might help if we flip this triangle around and actually line it up. Like line this triangle up with this triangle. Now we can see the n and the 36 correspond, and the 45 and the 30 correspond, and the 63 and the s correspond. So in order to solve for n, if I put n on the top, then 45 has to go on the top because it's part of the same triangle as n. And then I say 45 corresponds to 30, so that goes there. And if I did it this way, 36 over n, then I just have to flip it, and it should work. Cross multiply, or, you can maybe see these are both divisible by 15. So 45 divided by 15 is 3. And 30 divided by 15 is 2. So that makes it a little bit easier. N over 36 equals 3 over 2. I still kind of have to cross multiply. 2n equals 3 times 36, which is 108. And then I divide by 2, and I get 54 for n. Okay. The other one, let's just like cross multiply right away. See if we get the same thing. 45 times 36, 1,620. And that's going to equal 30n. And then I'm going to divide both sides by 30. 1620 divided by 30 is exactly 54. So either way works. Just getting one proportion correct is the main thing. Now, it also says to find s, so we need to use another proportion for that one. S corresponds to the 63, so I'll just do s over 63. But if I do s on top, then I have to put the 30 on top this time, and I'm going to compare the 30 with the 45. Just like I did before, just make sure s and 30 are in the same triangle, so they should be across from each other. 63 and 45 are in the same triangle, so they need to be across from each other. And now, to solve this, we cross multiply, or some of you, a better name is actually x multiply, because we're making an x right here. So 45 times s equals 63 times 30, which is 1,890. And then I'm going to divide by 45 on both sides. S is going to be 1890 divided by 45 is 42. Okay. So one more example together, and it looks kind of like this. You've got one triangle inside of a bigger triangle. And how do we know these are similar? If we know these sides are parallel, then these two angles are the same. These two angles are the same. And then R is the same angle in both triangles. So again, we know all three angles are the same. So now it becomes a game where we might want to draw out. The big triangle. That's how I like to do this. Just make the big triangle, and because we've got 10 and 5, so together that would be 15, right? But then this side, R through E to S, is equal to 15 plus whatever E is, the whole thing. And the 30 is on the bottom. So now I can compare the big triangle to the little triangle. I'll do the little triangle in red. Okay, so 15 corresponds to, in the little triangle, 15 corresponds to this whole side, which is 15 plus E. And then this other side, I know 10 corresponds to 15, 10 plus 5. Now that's what I need to set up in order to find E, and then I can get ES. Well, I guess I'm calling this E, but really it's ES. ES. So now how do I solve this? I cross multiply just like before. 15 times 15, and then I have to distribute 10 times 15 and 10 times ES. 10 times 15 is 150 plus 10 ES. And I have a little bit more work to do. I have to subtract 150 on both sides. 225 divided by 150 is 75. ES times 10. And now I just divide by 10. So I get 7.5 equals ES. Okay. So now how do I get EB? EB is this side, okay, which corresponds to what? EB corresponds to 30. Those are both the bases of that triangle. And now I can pick the same thing I did before. All right, if I'm comparing EB to 30, but a little bit easier way to do this is just to compare the 10 and, right, I know this side is 10, and that's in the same triangle as EB. So those are going to both go on the top because they're in the same triangle. And then 15 is corresponding to the 10. It's this same corresponding side here. So now it's a little bit easier equation. I can multiply 15 times EB equals 300, 30 times 10, then divide by 15, and I get 20. 20, right? 300 divided by 15 is 20. Okay, so that's it for similar triangles. Thanks for watching. Goodbye.